good start. Nevertheless, I was thinking about how we do this yesterday and day before for some time, and I had a series of chats already with Sanil some weeks ago, and also with Madhulika. And look at yeah. Solid. And then you put a theoretic gloss over it. But that's the shallow engagement. The other would be to just sort of, take a chair and say, this is what a particular philosopher say about such and such trope. And then you sort of, that's sort of an engagement. I thought neither of this would work, would not be a meaningful way to do it. And then still it's a challenge then, how do we structure something like that? And one experiment which we could do, and that became clearer for me in the morning. So I have to, in some way, restructure what I thought and how I do it. And one way I felt as an experiment which we should experiment with would be to pick up a contemporary situation or two and then to pick out in a particular way. And I thought we could try that. And that I felt I have three different things. Let me. Yeah. So I had three sort of different situations in mind. Let's see how much we can do, because point is not for me to talk, but I want as many interruptions as possible so that we can have a conversation. And it's just some kind of a bench I'm trying to offer around which we can just use. Yeah. And before I go into that, I just also want to use 5, 6 snippets I got in the morning. So I just want to put it so that we might really find them useful. One was from the corner, which said all science has evidence, but we just might need to know how to learn to have authority. So that really caught me. That's I thought that's quite a statement to make. And there was something in between which came like the medicine works, but I don't understand how. No, so that sort of again, yeah, going back to causality in a particular way, it works, but if you don't know how it works, then how is causality? No, it becomes a bit difficult. Right? Or a the hardcore medicine brought in, but no, that is not from here. Yeah. But economic choices about not diagnosis, but prescription. So how to treat and so on. Yeah. And hence, not only and hence, but including that, there are some political sort of way in which we need to understand that sort of um, and effect. And I want to come back to it in a little while. But why I want to do what I want to do in terms of focus on causality is a particular claim that it's a construct. And what do I mean by causality as a construct? And why is that useful in a minute? So there could be thought, the claim goes in some arenas that causality is a construct. Causality is influenced by geographies of academic training or at least correlation. What that is, again, I want to just put out the way I thought about the problem, and then we can take it in whatever way we want to. Yeah. So once you think about causality in sciences in general, but for us, we are not even simply interested in medicine, but in biomedicine. We also might have to end up placing that attention within this old problem of holism and reductivism. So we want to come back to that in a little while, if possible, and then think about what sort of a conversation, what are the varied responses we can have about the very nature and construction of biomedicine today. So that's the sort of what I'm trying to say then is that if and how we look at causality in our realm might very well have important ways for us to understand the very nature of biomedicine. Yes, that's the sort of suggestion which I want to go with to see whether that's possible, what sort of responses we get from the table to see in what ways that can be possible. Yeah. And also the last caveat is initially, as I was, I think, mentioning earlier, initially I was thinking about using biomedical research in terms of pharma research, pharmaceutical research, but I think it might work making it broader and not just look at only pharmaceutical research. Causality in pharmaceutical research, right? How do we interrogate, understand causality in pharmaceutical? Okay. So what would the others be in a second? So there are three sort of, so if we use this experiment of having a conversation about three snippets as opposed to taking up one particular philosopher and say so and so said this, what do you think about it? The three situations I had in mind was one was to use a bit of what me and a couple of PhD students I have been working with look at in terms of AI slash algorithm in health. So it comes across in multiple domains within the health slash medical sector, biomedical sector to a large extent. Around so one is there is this push towards diagnose a certain kind of diagnostic aid they say, but slowly, how do you in the last 10 years you can see digitized versions of diagnostics coming in a particular way, and where does that lead is anybody's guess. But there are multiple ways in which these technological strategies in other domains have gone. For instance, in long-term ecological monitoring, you have ended up with automatic hypothesis generation and slow and also automatic data collections across large areas of territory and time. So in that arena, it's played out in a particular way. That doesn't mean it necessarily has to play out in diagnostics in the same way, but there seems to be some suggestion that algorithmic application in these kinds of construction of large data sets is tied to diagnostics in a particular way. So there is one set of application in algorithms with this. Second is a little more controversial and very less in India around drug discovery, precision medicine, and so on. I wanted to focus on that initially, but we can. So, why do I focus on that? I want to try to understand what is the nature of causality which we can derive when we get into these kinds of drug discovery. Okay, yeah. So that's sort of a so and then you have other kinds of applications in through AI. You could end up with drug delivery, disease identification, diagnostics. Yeah. So there is this. So I want that one contemporary problem around which we can talk about causality through which then we could, the way we talk about it, we'll end up having some kinds of valuable insights each of us would have around the idea of causality there. And through that, we get a snippet of how do we understand biomedicine. Yeah, so then there is a conversation. That's one part. Second is what came out from today's morning, RCT. So from the 80s onward, we have had a very strong push, city generally, for empirical theory making, empirical science, and so on. But also particularly medicine, which I don't need to tell some of you. You would know far much more. I mean, I just have some kind of bookish knowledge there. So RCT. So again, we could inspect RCT, the kind of causal claims which comes out of the RCT as a way in which there is some guidance for expert or doctor-patient sort of an interaction, curing, treating, and so on. That's the second possibility. And the third is a slightly old problem, which is actually not about medicine directly, but it's about causality, environmental pollution, and cancer. So it comes back to medical causality in a particular way, but not in the classical sense, but more in epidemiology and biomedical interventions and so on. And this is something which I've followed for a little while. This is a particular case from northern Israel. And Israel is not some place we look at very carefully, and particularly since this is a case about Israeli defense forces, commandos getting cancer a lot. And because of particular ways in which we encounter dehumanizing from the the thing, we find it hard to think about Israeli soldiers as human beings sometimes. But there is something there which is very valuable for us, that case. So in this three, I want to see how much can be done. Yeah, but this is what I have in mind. Yeah. So, and coming back to why causality, I mean, if you think about, yeah, we've already talked about it, so I don't need to do very much. So I'm using, I've already done some shortcuts here. But if you look at it commonsensically already, if you think about causality as an event which influences another, so there is a dimension of future involved, and there is some way in which one bounded event can cause another bounded event in the future. So that's the sort of relationship claim which we are trying to engage with, right? So, and in some ways, it's a basic concept. Basic in the sense it's fundamental. It's also an abstraction because there is very difficult to say that smoking caused my cancer. Yeah. You can say smoking caused cancer. That too, it took so many decades, no? Sort of. I remember when I was a young boy, my father sometimes used to, I mean, now when you think about it, I don't know how parents do it. I had a lovely father, but he used to get me to buy cigarettes. Yeah. And then I was very curious about it. So that's the first time I encountered a cigarette packet was when I went to I think chemists used to sell tobacco at that time. The shop was the same, probably. And it would say I didn't know what statutory warning meant. That statutory warning, tobacco is injurious to health. That's what I remember as. And I didn't take it in. I just read it very mechanically. And I used to not even think what a statutory warning meant, the words. So it took some time for us to, as a community, to move from, and if you look at ads in late 1800s, early 1900s, tobacco is a medicine for virility, male virility, the Marlboro man and so on. And that was also science. It was those lab coat guys who would come on those ads and say so many things. So you have this science which told us to smoke. And then you have the science which at some point said it may be injurious to health. And to now, it's just sort of scary. I mean, I have smoker friends. They are all untouchable lot these days. No, when you go in airports, you'll see them in some glass cages and so on. And parties, I mean, somebody wants to know, just go to the balcony. No, sorry, and so on. But when you look at their hands with these packets, there is no what's it called labels. You have this big photos, no, this and that and so on. Tobacco causes cancer. But did tobacco cause my cancer? I'm not entirely, I don't, so I'm not entirely sure how will we be able to answer that question in a classical causal manner. That's what I'm trying to hear when I say it's a construct, it's an abstraction of a certain kind, where me and my friend might have smoked, actually, my friend might have smoked far more than me, and then I get this cancer, then and this guy has gone scot free. How do we then think about tobacco causes cancer? Did tobacco cause my cancer? and the tobacco did not cause this cancer. It becomes a little so it becomes in some ways to a limited extent. We can always answer this with particular frames, of course, that there are you can come up with. It's like coming up with explanations. It's in history of science you have this example, no, in 15th century or was it 16th century probably. There is this move in maps, navigation, right? Ocean navigation from the from the geocentric world to the heliocentric world, where the maps which described and assumed Earth as the center of the universe and Sun at the center of the universe. And surprisingly, when you hear it for the first time, the percentage of accuracy of the geocentric world maps were far greater than the heliocentric world maps. So then you already see truth claims and techniques have there are some connections, but not always. Right? There are ways in which sometimes tobacco causes, whatever. And at some points, it causes this big hole. So there is, science keeps changing. So when we talk about causality, scientific theories are also abstracts in a certain way, say some people, not necessarily me, of course. Yes. So there is something to do with that idea of the basic concept of causality being an abstraction. And today, I only want to, there are various ways in which causality can be cashed out for an engagement with biomedicine. But I don't want to go into the metaphysical or this is for the or the ontological aspects of world making and so on. I just want to only look at the epistemic aspects of how do we know what we know, and that really helps us shape biomedicine with practitioners in a particular way. I feel, yeah. So that's why I'm just going to focus on the epistemic aspects. Um, so if you look at Western philosophy, you end up with people like Aristotle, many centuries ago, trying to talk about there are five kinds of maybe I want to. Robin had specifically instructed me, and you can't deny the man because he's scary. There are, for instance, Aristotle would say there is five kinds: regularity, probabilistic, counterfactual, mechanistic, manipulation. So that there are different ways in which Western philosophers of science have cut causality in its abstractive sense. But I think we want to avoid getting into philosophy of science because it's going to take us away in a particular way. I think we should just specifically look at philosophy of medicine, in particular, if possible, biomedicine, so that we jump straight into the way we understand causality, with one caveat about which came up in the morning, I feel, where uh, there is a way in which authority is constructed. You are amenable to be heard by your patient because you have a degree, of course. You have other people coming in. There's a lot of, so herd mentality. She must be very good because there are so many people going in. But also, there is the authority of the lab coat somewhere behind you because you're scientifically trained. So, to that limited extent, your authority is embellished, rightly or wrongly, and it could be quite rightly, by the normative supposed superiority of a scientific method. So, to that limited extent, we need to have a little nod to philosophy of science. Otherwise, I think it's better to just focus specifically on biomedicine. So, these are the sort of caveats I think I wanted to start with. Hmm. So, coming back to construction of causality. The reason why I say construct, I think will become more clear when so if there's a particular death, for instance, because not every death can be equally self-explanatory, no? If you have a death by, you could have a death by cardiac arrest, you could have a death by pulmonary embolism, or you could have a death by lung cancer, right? All three are possible at the same death. So you can have lung cancer by genetic mutation, deposits of carcinogens in lung tissue. You could have cancer because of smoking. All this happen. So if you look at, or it could be because this particular person has proclivity to addiction, proclivity to peer pressure. You could have all these explanations at the same time. So for corona, the deaths would be for pulmonary embolism. For a physician, it's just lung cancer. For an epidemiologist, it's smoking or tobacco. Yeah. So you see, the same event can have three causal factors. The easy way to then characterize it would be to then say it's disciplinarily organized. So each discipline could end up having one kind of causality. That's the easy way. But if you enter into the discipline, then there is again, there are issues. There could be differences in the way causality is done. But you could say one way to cut it, to think about constructivism. So it's not scientific anymore. It's sciences. It's no one single science. It's sciences then. There are multiple sciences. Each science each domain could have different causality. So then the question is, now I have done a little bit of heavy lifting now. Now I want to open it up now. Then the question would be, if you think about your practice, sitting in front of a person whom you're meeting for the first time or for the umpteenth number of time, and you look at that person, you listen to them, and then you prescribe something. Where is that? Where is the locus of causality here? Is which How do you think about it? Because that's the and at one level you could say, the way say it's the medicine, we have particular knowledge behind us, tells us what to do, guidelines, RCTs, so-called scientific experiments, and so on. And but beyond that, how do we talk about this causality? That's the challenge, I think, here today. So, okay, now, hmm. So let me use an example to see how we could respond to it. So, because I want some response, gearing towards. So let me use this example which I was mentioning earlier about the what's called the Kishon River affair, yeah, in Israel. Yeah. So the Kishon River is this river. It's in the northern occupied territory of Haifa. It's Haifa and so on becomes far more under Israeli control after 1967, and so there is this river which is, uh, yeah, I mean, if you look at the territory, these are like smaller than Kerala in terms of river length and so on. It's a fairly small, short river. But it's also in the industrial heartland of Israel. So you end up, and also agricultural basins are nearby. So you end up with highly populated urban areas, which the whole of that part is. So you have a lot of domestic sewage getting pumped in. You have industrial waste, huge amounts of industrial waste. And like every part of the world, industries really control governments in particular ways, which means whatever the standard is, there is ways in which standards can be manipulated to ensure that it matches industrial affluence. No? So there is certain politics around it. And there is also this kind of agricultural stuff happening. So all these three things has been pumped into this small river, and then there was this. Uh, you get to know that Israeli commandos are also training in the mud, yeah, and then it becomes a ground for their training regularly. And there are snippets of how when young soldiers have to be punished, they have to start drinking the water and so on. It's just, this is probably what uh, armed forces do sometimes. But all things come to a particular thing when a celebrated veteran gets cancer, and then he feels it has something to do with his training. Then he starts calling his friends who or left the forces. They have conscription system, no? And then he starts seeing a lot more people having all sorts of cancer, skin, colon, and so on. So the hunch then is about, yeah, that there is a correlation at least. So, and then that snowballs, and Israeli defense has a high status in it's like Sparta, no? Sort of, you have to live off other people's. So it becomes a particular way in which the soldier becomes a heroic figure, and the soldier themselves having to go through this kind of becomes a major public outcry. All this to say that it ends up with a demand for accountability and to see whether this has cost their cancer. That's it. So defense forces as it won't straight away deny it and there is no such thing, blah blah blah. I mean, it just goes in that. And on the other end, the veterans are very clear. So many of us, there's a huge percentage, 80 odd or something. We have got these kinds of, and then this has happened. And they end up with a commission of inquiry, which is a very classical way to sort of, whenever there is public controversy, prolong it. But also, that's being facetious. It's also to find a particular rational basis. So here, they end up with three experts in the committee. One is a biomedical person, a scientist, a white lab coat. Second is an epidemiologist, and both of them are scientists of certain kinds, I suppose, right? And then the third is a particular character, and is the glue who everybody has trust over. He is the earlier Chief Justice of the Israeli Supreme Court, and surprisingly, Israeli Supreme Court and fundamental rights, the Bill of Rights, was universally well vested. It's funny, no? But in the Western world, the Israeli Supreme Court is supposed to uphold human rights. So, but who is a human? That's a different matter. So you have this figure who was the earlier Supreme Court judge, Chief Justice. He was a war veteran who got medals of all sorts. And so everybody is happy. Defense people think he's our man, he will do our thing. The veterans see that he's our man. And he's an bipartisan figure. Those days they had two strong parties, the Labour and Likud, and so on. So, what happens after that? To see whether, so there are four questions framed, in that. One is about what's the level of carcinogens in the water? That's fairly straightforward. You could measure it in a particular way. There are difficulties in measurement there, of course, which takes us back to disciplinary roots of causality. About do you take every carcinogen separately, every chemical separately, or do you start thinking about it cumulatively over time, or do you also look at the synergies between different chemicals? So there are multiple aspects there, but we'll just keep it simple, right? Sort of there is are there enough carcinogens in the water? Yeah. The other is what's the sort of exposure these folks have had. So a quantitative analysis of how much time they were under training in this, so on. And the third is has this caused that? Right. So and then this goes on for a number of years of deliberation. It doesn't. Here you end up with particular story where you would straight away imagine the biomedical person finds it very difficult to ascribe causality in such a deterministic way that this is caused because you let's say there are 80 people who have got cancer, veterans. You what is the sort of control group you can have? What's the sort of cohorts you're gonna break them into? What are their genetic makeups? What are the other habits they have? What are the so there could be multiple other factors which makes a causal description very difficult for a biomedical. You would imagine for an epidemiologist, it's a bit more easy for the way epidemiology works, right? You could, and then there is this curious animal, a lawyer of some kind. This goes on, and it's a highly explosive situation because of the particular nature of the society that they are. And finally, surprisingly, both the scientists, supposed scientists, say no, we can't see causality in that absolute sense. But the war hero comes and says, "This is all okay." But in law, there's another story. But here, the difficulty of causality comes about very sharply because in a commonsensical sense, we can see there is definitely some reason why these many people have got causality, and yet it's not easy to do it. So, as doctors, would you be able to say there is causality? That you are not there because your face is different, right? But if you invert it and go into pharmaceutical research and see what causes cancer, what can alleviate further growth, you have to get into a particular way. So, what sort of causality, what frame of causality would help you? That would be useful for us to hear, to discuss. Yeah, sort of. That's a sort of proposal I have on that. Second is in RCT. Yeah. So RCT, when you go back to so now we are going back to biomeds. In biomedicine, little bit of uh, colonial history would be useful, no? Sort of, because if you look at it as a history of Western science, there are historians of science who would talk about how a particular science, biology, for instance, botany, colonizes the knowledges of the other. So I don't know whether you would have read Amitav Ghosh, for instance, that trilogy, no? That Sea of Purple trilogy. There's this botanist figure there, and it actually is a figure, a historical figure, which Amitav Ghosh encounters in the archives. And if you go to many old European, Western European university towns, the herbarium is a central part of every university town, not a university, university town. It's so central. I have a friend whose husband proposed to her in a herbarium. So it's a very central sort of act. And what is a herbarium? Herbarium is a place where these plants are brought from colonial lands using colonial knowledge, colonized the knowledges of the colonized. And that's just a very Amachitrakatha example, right? But if you look at how knowledges have been colonized, so say the historians of science, you would see a certain extractive nature in which local knowledges have been appropriated and used in a particular and claimed in a particular. That's history of science of a particular time. But if you look at how Western biomedicine gets its root in South Asia, for example, or in many other parts, you see something similar. It's an analogy. It's not necessarily the same. You see contestations of knowledge systems coming across in a particular way. So I have to go back to where I was. Sorry, give me biomeds. Okay, sorry. So yeah, so you already see a particular kind of history through which biomedicine takes root in India, for example. It's that is not to say that biomedicine is not a valid scientific thing or a valid scientific thing. It's just a history. And the reason why I invoke the history is also because it is tied to how biomedicine becomes the dominant frame of health in India. That is not to again say it's efficacious or not efficacious. There is a history of how, and tied to this history is also a history of how it has become so. It's not just through the sword biomedicine becomes something. It's also there is a particular acceptability, a public acceptability. There could be ways in which it was given more economic scopes or whatever. Beyond that, there is a public acceptability. Just like there's a public acceptance for English. It's, it's a way in which we think. It's and that's tied to scientific method. Yeah. So that's we come back to the no, the supposed normative superiority of the scientific method. So definitely, and that's again, I want to emphasize again and again, when I'm describing it this way, I'm not saying I have a problem with that. I want to describe it so that we localize the way we think. That's all I'm trying to do. Yeah. So once we enter biomedicine with its ideological backbone of Western science, you then see an old history for our city. Okay, because you and it's not that biomedicine is uh, uh, native to Western Europe either, because just like biomedicine pushes certain kinds of knowledge, medicinal knowledge systems here, biomedicine also has pushed out certain kinds of medicinal knowledge in Western Europe, right? So in both, scientific method becomes a very valid way in which that conversation, that pushing is happening. And I say that again the second time because we also have this ways in which practitioners end up having a particular way to understand it across the table with the patient. You know? So there is a knowledge which is that intuition doesn't come quickly, but it does come for many people for sure. Yeah. So how do you discipline that intuition? How do you make it into something which is quantifiable, which has, like, you don't need to be scared, no, if you have a guideline, right? So yeah, so that sort of, so that's the idea of evidence which we have then. It's what is the evidence? The meaning of evidence? Evidence of due diligence. The evidence which we are saying that as a doctor, I am in a tough spot because if I exercise in a particular way, I might end up with a lawsuit or patient's family coming and beating us up, right? So there is a real danger, of course. But the evidence there is that evidence of your due diligence. But what, and for RCT, for others would be, there could be certain kind of interest which will help to prioritize or to commercialize one set over the other. There could be various, or there could be just simply the classical scientific idealism of finding out efficacy. So there are some multiple sets of possibilities there, no doubt. But then you go back to RCT, what do you see? When you go back to RCT, you encounter the claim of causality from that of a classical, what's called as a logical positivist claim of late 19th century to early 20th century. what that is in a moment. But that's what people would say. I'm not saying that need be the case. And you would then end up saying that this is scientific. We have scientifically proved that this is more efficacious than that, or this will cure this, and so on. That's the claim. Then you end up thinking about the relationship between. See, right now, this is looking like a monologue. So I'm getting a little trouble, but I will continue. And whenever you feel like stopping and pushing me, you do, because, it just goes on for me, right? So please feel free to just, okay. So here, then you end up with what's this RCT about, causality in RCT? You will end up saying that there is a way in which we know the truth. Okay, truth is a bit, and now I'm being a straw man. I should use something a little more, a little less. So here, you are saying that we have done experiments, and through our experiments, we have proved a certain hypothesis. That I think is reasonably acceptable. So we leave truth out of it for now. There is proof. Then it will come back to the morning question of n plus 1 in a particular way. Yes, please.
Yes, I think we look for, we think that there may or there may not be an association. So, uh, and we use logical reasoning to see whether there is an association or there is no association. But we kind of also try to take a position where we refute that. So it's like the we think of four possibilities. In reality, there is an association, but our finding doesn't give one. In reality, there is an association. We find it. In reality, there is no association, and but we get that, or we get the opposite. So we have these four possibilities, and in each of the four situations, we kind of draw the line that there is or there is no association between this particular. Then we load on many more ideas to this whole thing. So what we find may be because of chance. So then that brings us a whole lot of probabilistic thinking that so we try to say that what we saw is because of chance. So we try to rule out chance or minimize chance. So it's like there is no absolutely ruling out, but we try to minimize through certain probabilistic techniques. Then there's bias, and bias could be, to say in a very simple way, related to selection and measurement. So I am saying that one concept is leading to the other. So how have I defined this concept? How have I defined the other concept? And to say that this person, this unit has that, and this unit does not have that, there's a measurement there. And so another thing is, no measure is perfect. Every measure has what we call sensitivity and specificity. So misclassification is inevitable, and we have a whole school of thought on related to misclassification, differential misclassification, non-differential misclassification, etc. Selection bias is another. Did we select the right kind of people for this? Again, to some extent, this concept of population and sample comes there, and is our sample. Representative are our findings. Generalized, these terms come into it. Then we have the covariate problem. So then we need two groups if we are studying two groups where the covariate, again that brings us another word, distribution. The covariate distribution has to be comparable. We have Aristotelian counterfactualism coming in there. So if I get a situation which is very close to the counterfactual ideal, so except for this particular thingy that I'm measuring in one group and the other group doesn't have that, everything else is comparable. How far away or how close to that situation am I? So I have to ask myself that question. So there's chance, bias, covariate considerations. And at the end of this, what do I get? I still don't get the answer whether for one person this exposure led to the other. Because if I look at individual units, there would be a person with the exposure and the outcome, the exposure, no outcome. No exposure, outcome, no exposure. So what I'm getting is a finding of the average person. So, and I don't know whether this average person is a real person. For the average person, this may lead to this with considerations of chance, bias, and only covariate. And just to, just because I am tempted to say this, are we thinking only of cause and effect in terms of sickness and uh, a cure, or are we thinking of prevention to make things more complicated, enhancement?
Do you think diagnosis and preventive medicine is different set of published? Would you similarly prognosis, pharma research, the frames be different for each of them? What do you think? When there's a goes from on public health, epidemiology, again, what are the kind of ways in which public health is tied to prevention again in some ways? Not always, of course. There's also bring that. Yes, so it would be great to what is the ways in which it differs according to you?
So there's a lot of work in our institute on iron deposition, and there is this condition called motor neuron disease where people slowly lose their Stephen Hawkins. So and so we lose our ability to move our muscles. Slowly we lose the ability to speak clearly, and finally breathing becomes difficult, and you die. So that's motor neuron disease. So we were looking at iron deposition in different parts of the brain. The brain is a very, very complex thing, which has gray matter, white matter, white. So from one part of the brain to the other, the gray matter, white matter ratio keeps changing. So, and in that context, we looked at uh, iron deposition and whether certain pattern of iron deposition leading to faster progression or slower progression. So if people have more iron deposition in certain parts of the brain, they worsened quickly. Whereas if they had less iron deposition, they probably, I don't know. It was a question that everybody has autoimmune disease, so whether it's really nice, you're going to die sooner, you may live a bit longer. But that's one kind of work. The other kind of work is cognitive impairment. Let's not talk about impairment. Cognition. What is normal cognition? I was part of the ICMR neurocognitive toolbox development. So we developed a toolbox to assess cognition in all of us. The basis for that was that many of the cognitive tools are developed in the West, and cognitive tools are inevitably linked to language. And Western language, the what you say, semantically can be very different from Indian languages. So we needed our own tools for assessment cognition. So there is this 2.5 hour battery. So it's a cognitive battery of neuropsychological tests. Once I can administer the battery, I can say whether somebody is cognitively normal. One of the challenges there is regarding normal cognition is that it has about 350, 400 variables for each individual. So how do I decide somebody is of normal cognition? So that is also evidence, and that is not something we can arrive at through RCTs. So for diagnostics, as you were saying, we look at other attempts of validation, and maybe over time we see whether we predictive validity, like we say, whether it's predicting actual. If I say that somebody is cognitively in one position, somebody else is in another position, and then waiting for over time to see whether it's predicted conversion to Alzheimer's or not would be the way. But then RCT is definitely not. And this is a very, very pressing concern today in our country. This was a huge exercise that we did with almost all Indian languages and geographical regions. So that's something. Then regarding wellness, we have this lot of positive mental health, resilience. Uh, so to say that somebody is coping well, what do you mean by coping well? And we have adaptive coping, maladaptive coping. So when is somebody coping maladaptive? And when is somebody coping in a positive way? How to measure that? Again, I think we are looking at, I don't know if I'm diverting this talk, but a lot of this, I think, doesn't, the RCT is probably not the answer to much of this. So RCT, yes, in specific situations, uh, we can probably understand. And I think, to the best of my knowledge, RCT is something we borrowed from agriculture, where we could have, you know, if this place where the weather conditions may be similar, you can have one kind of fertilizer versus the other, where it could easily be loaded. Whereas in for some reason, yes, RCT and meta-analysis, systematic reviews, meta-analysis remain the theme of evidence still, but then I think for many of us, evidence is much more than.
I know the medicine is working, but I don't know how. If you don't have that knowledge element, in what ways that can be considered as causality? It becomes difficult, no? Do you see the difficulty? I don't know. I don't know. Typically, you, as a practitioner, you could say there is a causality, not because you have seen the causality yourself, right? So like someone like David Hume would say that the mind can't directly access causality. It has to come from a particular frame. So then we go back to the frame, and the more you look at the frame from which the causality is supposed to produce, you don't see the causality there so clearly. So, how is it that then in biomedical frame, how do you make a difference between correlation and causality? You can see it work. It's like I have a friend. He's a radio astro, not astrology, but astronomy, right? Yeah. So this is a friendship from the 90s. We used to go for rallies, protest together. And he will always balk at me when I have my little sugar balls, no? He'll, oh, placebos come, placebos. But, and then I'm having my medicine and it's working for me. But that working is not enough, right? To have causality. For him, causality is not about working. It has to be particular kind of scientific. Otherwise, but is that particular kind of scientific? the medicine is not efficacious, it's still scientific. So then how do we understand causality? It becomes there is some slippery all I'm trying to do again and again through multiple ways to say that we keep hearing that correlation is not causality. But there is, to my mind, I can't see a clear line. When is it that correlation becomes causal? There is, and I want to understand from voices how does that happen? So that will be very useful as that's the point of what I'm trying to do in this session. So that you can always have, okay, according to this protocol or that protocol. But then we enter that protocol and then we go beyond. There is again a radical difficulty. When you look more carefully, maybe it's the lack of training, or maybe it's a particular training which you have. But I'm yet to hear a convincing answer of the gold standard of causality coming out of these sort of things. And this is in the context which I was originally wanting to talk about, was in the last 15, 20 years, you have a particular way in which it's called a data turn, no? So, okay, as if there were no data before this turn. But there is a particular way in which large scale aggregation of any kind of relevant data is happening in multiple fields. You use, sometimes they call it big data, sometimes they call it data aggregations, machine learning. There are various tools which are used. You have all sorts of sensors. In ecological data, you can see all sorts of wireless sensors scooping up like millions of data points every week. And these are all getting into a particular kind of a system. And that's really not any different from uh, uh, a health in terms of the data points, right? So, and you see similar trajectories of health research, for instance, in public health. You see certain kinds of ways in which preventive measures are thought about now. It's, the measures have not reached there, of course. And this all takes us back to questions of causality in this particular way. That in classical environmental regulation, you started off by saying that we have to stop pollutants because it makes harmful effects on bodies or other identified bodies like a lake because of, again, back to our bodies, or a bird because birds are signifiers of what will happen to our bodies later. Look at fish, so much microplastic is going to come to us. And you can coming back everything to the body again. So environment regulation, you have a move by this is something which you're talking about later, right? In quantitative risk, you're getting into risk factors. So from causal factors of a hazard variety, you've entered risk factors by the 80s, right? And when I say risk factors, what do I mean? I mean there is a certain statistical probability sort of. So across causality, you end up with a certain probabilitization. When is that a correlation probabilitization stop, and when does a causational probabilitization start? It's very difficult in theory. It's not difficult in practice because somebody says this is it and that's it. So there is no difficulty in practice, right? Authority, right? But in theory, is really hair splitting. And I don't know, maybe I'm just an illiterate. I don't understand that. But I'm not sure, so sure about it. So coming back to the environmental risk assessment. So you end up with a history of environmental risk assessment where you are trying to manage the future uncertainty. Because when you say probabilitization in risk, what you say is that you identify certain possible adverse consequences, which we name as hazard, health hazard, etc. And then you put a number to it through particular kind of statistical. And then we know in a history of 20 years or so, no, these are not really working. You have uncertainties outside of this risk calculation. And then you try to manage the uncertainty. That's the word you use, no? The particular word you uses. particular distribution. So, so then the uncertainty framework is also not working after something. Then you say complexity, ambiguity, then you say ignorance. So you have this family of terms coming out of environmental regulation, which talks about trying to control the future. And that causality, we are trying to control the future by saying that this causes this through time. And we make a certain quantitative. So it's not RCTs and it's not just experiments in what it has to be it has to be through time. So it is probabilitized. Already it's in RCTs is already probabilitized. And you can see the link to the earlier 20 years old environmental risk assessment process, which is also a health assessment process. Because you end up when you start doing environmental risk assessment, you end up looking at the body, the human body. Without that, you don't do environmental risk, right? So that's it's not saying that's the entirety. One could argue it's the entirety, but it's not necessary. But human body is the center object, target of environmental risk assessment, probabilitization, causality.
It's just that we see some sort of a relationship between the two. Could be uh, an inverse relation or a normal relation. But if you're able to identify one factor, or if you're able to single out one or two factors, and if you can identify the pathogenesis, that is what change it is causing in the body and how that is producing the disease or how that leads to the disease, if that is established,
You're saying one case, just one case.
no, like with one case you might have seen how it caused some particular change, and then the similar next case comes and you see if it has happened, and through multiple cases, if you can, after some cases you can establish that this probably leads to this kind of a pathogenic change within the body, and this is how this particular organ system is affected, and this is how this leads to disease or death, then you can assess it, then you can name it as causality, that you then you have an evidence to say that this is causing this. We are saying this because this pathogenic things are happening within it. But for the other thing, but the other way, I think what it does is you are trying to see how you can control or rectify a situation based on the fact that uh, which is more like those who are exposed seems to have this thing more. So this is probably because of this, and let's control this and see how. And that is why often sometimes the existing evidence changes after some time. When new knowledge comes, the existing knowledge may change. And that is because in the view of new technologies or new knowledge, the way we assess it might have changed, or the way we define the diagnosis might have changed. So there are various things happening there. So how I understand is correlation is when you observe a relationship between two variables and you are seeing whether that observed is as so much earlier, whether it is due to chance or you can address it, whether you can attribute it to bias, like that. That is why we say probability, p value, because it is a probability of, usually we as a standard we either take zero point 0.5 or 0.01 and we say if it is less than zero point 0.1 it is statistically significant. And what we are actually saying is that the probability of the observed difference being due to chance is less than 5 percentage. So 95 percentage it is going to be not due to chance. Even when we frame those sentences, I think we are very careful in framing those. We never say it is true or anything. We say that less than 5, only less, the probability of the observed difference being due to chance is less than 5 percentage. That is the statement that we are making when we say probability is less than zero point 0.5. P value is less than zero point 0.5. So I think that is there. And then coming to causality, I think causality can be established only after considering various other factors. For example, in case of, okay, now that I have listened to you, I find it very difficult. explain causality. Earlier, it was very easier for me. For example, there is COVID virus. You have isolated the virus, and then you see that what are the pathological changes it happens in those who have COVID. What are the pathological changes? Maybe there is increased capillary permeability, or there is some changes within the liver parenchyma, actually leading to some other pathogenic process, and the person goes sick. For some persons, it may not be there. For some age group, this is more. Someone with diabetes, it may be more, or some other comorbidities, it may be more. And that is how we look at that process. And I think it is, if you're able to demonstrate that pathogenesis, you can probably call it causal, but otherwise, it is correlation, and you're trying it out, and it can change, but it may not change.
Everything is multifactorial causation. Pittenkofer, you might have heard of that. So nothing is from one cause. It's always a combination. Then with germ theory, people kind, and then we had the miasmatic, that bad air and miasma. And then even when John Snow did his experiment with cholera and that water pump, he dismantled it. Vibrio cholerae was not isolated. I think I can connect it to what some of the earlier things where we didn't have the exact causation, but we did control. So it brings to question whether we really need that final nail in the coffin that this is causal or not before we can act is what it brings in. But the germ theory kind of uh, brought in the concept of specificity, single cause, single, and then over time that became challenged. So everybody was looking for a bug for every disease. Till slowly people said no, some disease like uh, Pittenkofer, I mean, not Pittenkofer, Pellagra, and that Goldberger. He said that it's not to do with a bug, it's something else, probably nutritional. And then we had Ross, malaria, and some even very unethical experiments by the person, yellow fever transmission he discovered. No, so from there things started changing. But at some point we had the RCT coming in with TB and streptomycin, and that reinforced the biomedical kind of thinking going on. And then that kind of persisted with the Human Genome Project and again looking for them. But at the same time, this other axis of thinking has sustained. And today I feel the multifactorial causation, the miasma theory continues to persist with maybe in a different name, like syndemics. Syndemics, where we have, you know, clustering of diseases and socioeconomic deprivation together. So, and those who are arguing for a syndemic approach in health are saying that why are we looking at TB separate from drug abuse with mental health when all these are clustered along with poverty and bad sanitation like that, which is when you look back very similar to the miasma kind of thinking. So I just wanted to.
I was just wondering about how you describe about causality and the real problems related to the causality. For example, in for a physicist, the very claim that water boils at 100 degrees Celsius, the sentence does not end there, right? He also says something extra, to that in order to make the causality aspect evident. He says, like, suppose if I boil water in my house, it won't boil at 100 degrees Celsius because I am from Wayanad. I am too high from the sea level. So water boils at 100 degrees Celsius only at the sea level. Okay, conditions are very clear. So the causality point can be very directly, you can really catch it up. But then there is another thing. Water boils is also another thing. He says even when he says it's water boils at 100 degrees Celsius, he is not saying that it's really the water that I drink. He says H2O boils at 100 degrees Celsius at sea level. So basically, what we usually call as cause and effect and everything is well arranged in a very sentence. Hmm? What is cause, what is effect, at what point of time, and everything is well waved in that sentence. But why? Because nobody ever experienced H2O. All of us in the natural world, we don't have H2O. In the sense, hydrogen's two atom plus one oxygen. Because every time in the nature we have impurities along with the in every water. So no water boils at 100 degrees Celsius in a real condition. Because there is impurity. If there is an impurity in the water, it won't boil at 100 degrees Celsius. So which means that the very description that science bring in about the H2O boiling at 100 degrees Celsius, where the cause and effect is a fictional activity, very fictional activity. So the same as something like a triangle. So then the cause and effect in such a kind of precision is possible only in a theoretical framework. In a natural framework, it won't because there are impurities. If you bring in those kind of cause and effect, a cognitive activity, which is a cognitive activity that we understand an event through cause and effect, we break it into a cause and an effect, then we stitch in time and space along with that one. So then we have that narration. See, if you're bringing in that narration to biomedicine, okay, so the number of impurities are too high, okay, then the cause and effect won't really working therein. So what is so much wonderful about it? Why you need the very idea of social construct is another complication, okay. So it's a natural, in the sense it follows. So the very debate about cause and effect, I don't see anything crucial happening at all, because from the fictional to the natural, we have a clear protocol. Impurities added to a certain level. When it comes to psychiatry, we will see that too much of impurities. Then what? So what is this debate about cause and effect then?
Ruben made that interesting point about fictionalization. I think you're Ravi, right? Ravi made that point about these limitations and impurities in, say, statistical research, right? So we know that in physics says water 100 degree centigrade. As he says, it's not the water which we drink, right? So there are a lot of things, there are impurities, then movement. If I try to measure the movement, there is friction there. The same way you said how there are problems in statistical studies about bias, about chance, about covariance, etc. Now, are these same kind of things? That is the issues, right? Are we doing the same kind of issues? Which I think it is not. Because, as you say, when you have any dream of translating a correlation to causal relation, you need to talk about counterfactual situations. Right? Suppose if it is not there, it's not there. Now, in science, there are universal laws to give a framework to do this, right? Now, in medical science, at least people like outsiders, you don't have anything like. What you have is a dream that late now we have only correlations, but with finally we will show their grounding in physiochemical processes, then we will have everything will be a law. But as you know, science didn't start with correlation and later matured into law. Physics started with universal law, right? So now, so first of all, about these things, can see every science has its own limitations. So statistical analysis will also find out, as you rightly said, RCT has a validity as one among the parts of evidence based. The whole lot of other things you cannot use really evidence based things. So we understand the limitations of RCTs. The same way we might say that look, the kind of limitations of their study, the medicine researchers understand, there may be something else, which are the real problems with it. Right? I think one of them is this sheer absence of any universal laws. Now, for me, I think it's a very good thing that medicine doesn't have universal laws. because this idea about universal laws giving content, even science might give up. Because my own dream is that in 100 years, physical research will be done by robots, right, with big data, and they will do away with this need for universal laws, right? So physical research can also be done like, maybe there is something positive, but the talk that finally this correlation become this causal, that in my way is limiting even the radical potential of medicine can have. That's why maybe we can have a really open discussion about how do we see this connection between uh, them. Maybe it's a good idea to do away uh, with them. That's where, for example, something like placebo. How do we think about placebo? For example, I take homeo medicine once in a while, but my allopathy friends tell me it's not placebo. Now, what is the but the interesting thing is, for a homeo doctor, placebo has a theoretical work because homeo works by placebo, logic placebo. By saying it's placebo, it is because, for example, it works with a very resemblance paradigm. So, aconite is a cure for eye diseases because aconite lead looks like my eye. Right? That's the correlation it works with. So, looking like is an epistemic principle in homeo. So, the doctors themselves will give you. Sometimes, they say that when you ask you to say two medicine, one of them is just water. Right? So that is what. So when we use placebos to explain things, we are already committed to certain kind of limitations of statistical research, not only strength. So that's where if we can open it. And I also wanted to ask you about this. You placed it in the question of legal evidence. So one of the question is that what is the nature of evidence? What do we mean by evidence in this, right? So how much of this medical evidence is actually legal evidence? That's what the question which you also posed. Like they're translatable. Are the evidence which is produced in the kind physics, chemistry laboratories produce, or are they the evidence produced in court? Right? There's a difference. In fact, totally a cultural studies context. This Walter Benjamin says about the discovery of photograph. Like when photographs became a trustable evidence, right? For example, a badly taken photograph in my ID card is an evidence, but not a very good picture, right? Portrait. Photograph has a certain evidential validity. And my own thing is that if I became the Prime Minister of India, I will make mirror as the ID, not ID cards. Right? You look into it, you are there. Right? Huh? No, I show it. I show my ID card. So I will look my mirror and show it to him. I hope there will be a notion of identity which will be. But how he says about the pictures of Ache, the famous French photographer. He says Ache made, when his photograph of Paris street, every Paris street a photograph of a crime scene. But he meant that every photograph can potentially be produced in a court. Right? If you don't see it, that Yadongi, that blow up cinema, it's a Hindi version of that also. The Yadav. Do you remember the Hindi version of blow up film? Well, basically, there is a normal photograph. So somebody dies. When this normal photograph, somebody accidentally develops it, you see the murder scene there. But nobody expected it there. Right? That's the idea that every photograph in principle can count as an evidence in some murder case or other. Now, that's the way in which something become an evidence. Right? For example, our classroom, how can it be evidence for some case, some claim? I think that transformation, if we track, then we will get some idea about what is evidence in a medical.
The moral weight of the, I don't know whether it's, I think about whether it's H2O and free of impurity or not.
Maybe there's a situation where it's morally very important, whether water boils at 100 or not. But then other things considered, sometimes moral weight here is deciding not to use endosulfan or deciding to pay the families who are probably affected because of the usage of endosulfan. And I think that we still don't have an answer on whether endosulfan really caused all that problem. And that's why I think we go for things like, so for example, in that particular situation, it would be something like, uh, it doesn't say, we don't have evidence to say this caused it, but then does that mean it didn't cause? So the other question also is there. And so precautionary principle would be to consider that, because moral weight will be there to prevent harm. So that is something is like. And then to what extent do we think of evidence when we practice in a clinic? I don't know. I've looked at many repeat all. So person comes with a prescription, repeat all. I heard Madras Medical College had C in the OP for repeat all. I don't know if it's true, but somebody said they studied in Madras Medical College. I don't know. So that is there. In Calicut, when 20 years back, we saw that most of the fever patients, when they are discharged with PEO, pyrexia of unknown origin. So we really are not knowing what we are treating. So next question is, but if the person gets better, then do we really need that definitive diagnosis? Common cause of death in our country is cardiorespiratory failure, which translates into heart stopped beating, which person stopped breathing. We really don't get the exact diagnosis in most of it. And that's why we had very complicated methods of verbal autopsy, which is becoming recently current thing to find out how somebody actually died. So, yeah, sharing this.
Sure. I think the challenge is not to ensure that we don't conflate it to philosophy of science, which it is not. It's what I'm trying to uh, think about is that there are various kinds of causes, and we take the causational question in biomedicine for granted as if it is something. And if you sort of look at it with a little more care, I feel the core commitments, not necessarily political commitments, the core commitments of biomedicine can be revealed a bit more if you take the varied kinds of causality, the geographies of causality in biomedicine. That's what I'm saying. I'm not saying there is no causation. What's the that's really not a so that's sort of in that sort of thing. Just also to add evidence, we need to talk a bit more later as well. But there are again, I'm using the word geography again. There's various kinds of sciences. Regulatory science, regulatory. If I sharply respond to you, at the same moment, you have small scale studies which would claim causality. And when you end up in a court of law, like the WTO tribunal, you have umpteen number of cases where both sides will have scientific studies. Are we saying that one is scientific and not the other? No, both are scientific. In one particular border, side of the border, regulators would say this is causal, we have to ban some. And the other side of the border, they won't. It's not that one is scientific and it's not, the other is not. There are particular ways in which particular states would look at causality. The proof of causality could be different, and that's outside of science as well. Right. I mean, if you look at the EC hormones case or the asbestos case, in every such, there are at least 6 controversial cases in the first 15 years of the WTO, where it's exactly on this. That they show scientific studies to say there is causality. And then there are other probability studies. We will include these very same scientific studies. We include them and then probabilitize it out and say it's not causal yet. Maybe there's a correlation. It's not so simple to say that, we know and at some point it becomes that. There is something more to be said, and that is outside of science. And how do we understand that? Because there is a certain ways in which our core commitments comes out. And so.
Much more than what you say that there is no causal link. People are now arguing that the stricture with which you have to prove that it's a causal case is far more than what the other party will accept. So that's also the degree of causality which you demand.
So when you're in the field, there are certain things that you hear. So one of the authority, one person who was in charge of it, but he told us there's actually no evidence as to say whether endosulfan has caused this or not. And in the initial part, what the people wanted was they didn't want to be associated with endosulfan because that was affecting them badly. Their women were not like the children; they were not able to marry, or they were not. There are some social issues because of they were associated with endosulfan. And later, after it became very political, and then there was a monetary benefit, and then everything changed because one group didn't want to be associated with endosulfan, and then one group wanted to be associated with endosulfan. And when I was practicing there, I could see that people with diabetes, people with hypertension, they're all come with the prescription saying that this could be due to endosulfan because that is what the MOs has to give them a certificate. So in that, what they will write is they have flu. Like for one, while I was working there, I had to go through some 10,000 cases to sort the cases to whether to see whether they're there was some tribunal or something, so that I had to sort the cases. And in that, people with flu or cough or nasal discharge for 2 days, and the MO right could be due to endosulfan. For for very simple things, they will write could be due to endosulfan. So that is also there, I think. When you talk about evidence, what evidence actually stands, what we need as evidence, I think it differs.
Actually, as a it is going above my head, in fact, because I am thinking, see, we cannot sit in front of a patient and think, is this real water which will boil? No, we need to have something concrete. We cannot philosophize with a patient who is sick and suffering, saying maybe this medicine may help, maybe it is not the reason, maybe TB is not due to this bacteria. Should I give this medicine? I cannot do that. I need to have some picture, at least 80%. I should be sure what I'm treating, and I should find a solution for that. What maybe these are all important in the background, but right in front of the patient, I need something, somebody's help, some consensus where I can give a solution. So I don't know this causality, whether it is how much, because we need a real clear cut answer so that we can act upon it. That's my.
Homeopathy, they give same medicine to any disease. May not be true, but I have seen same medicine is given for flu, same medicine is given for cough, same medicine is given for some muscle pain. So the same medicine can be given for different conditions. But if they eat the different medicine, the same medicine for different condition, they develop something, even the patient will not complain about that. Because in this patient, it didn't work.
Child, 11th standard, post vaccine, Guillain Barre syndrome, that's what we call, and still not functioning the pre-vaccination level, and because of the lack of causal evidence, the state is not compensated. So it's a very, very poor family, and this was a son, and you know the value of a son even today. Despite all our argument of equality, a son is a son. So this is in Kerala, in Trivandrum, right under the health minister's nose. But then that's it. State failure. The medical officer PHC has returned, palliative care medical officer has returned, but the state has not. So when do we separate the state from the discipline, or can we not do that? And we have people who stopped TB medicines, went to homeo. The homeo doctor said, don't take that medicine, and then they worsened. So that's also there. But then, I don't know, I'm just, for the sake of argument, putting it out. Experience the person brings. For us, sometimes we are in a rush to label a diagnosis and prescribe a treatment. We don't take the extra few minutes to validate the experience the person comes with. And so when somebody else provides that validation, and so I'm sorry, ma'am, has been asking for tea. Yeah, but just this, I'll just say this and stop. So I've lost my L4, L5, L5, S1, two discs in my spinal cord years back. And it's a real bad pain. And I'm still not fully pain free. But when I took the MRI to my best friend in the neurology department, who's also my classmate from school, we have written, published together, and he says, looking at the MRI, this doesn't look very painful to me. So I am there. He is my best friend, classmate from school, looking at my MRI and this doesn't look very, don't bother. So I'm like, I can't sleep. So that is validation. So that sometimes the homeo practitioner or Ayurveda practitioner may be providing. I don't know, just the idea.
Just a comment on the vaccination. I just gone through the complications of in say smallpox vaccine. So smallpox was eradicated from the and the complication you can see around a serious complication of post-vaccinal encephalitis, that is 12 cases per million was there, and of that around 30% it is fatal. So, you can say these are the complications of any, I can say kind of a vaccines or anything. So, but we need to think about the prioritize what are the benefits. So you cannot say 100% safe medicine, or rather can say legally safe, or rather can say, what do you say, medically safe? What do you say? Use of medications. All those things are now, you cannot say 100% everything. All right.